Problem number 1, we are supposed to use properties of exponents and or logarithms to write the expression in another form. So we see that we have a fractional exponent. This is also known as a rational exponent. And if you look at the properties or definition of rational exponents, you will see that if we have a to the m over n power, we could write it one of these two ways. Notice that the denominator is the bottom part of the fraction, is the root number, and the top part of the fraction is the exponent inside the radical or even outside the radical. So for number 1, we see that 3 is the denominator, so that's the root. The numerator, or top part of the fraction, is 2, so that would give us the third root of m squared. For b, we notice that we have the log, and there's a power in the log. So if we look at the power property for logs, we see that the exponent can be kind of pulled to the front of the log expression, connected with multiplication. So for log of b to the fourth, we could rewrite that as 4 times the log of b. And then for c, we just have log base 7 of x. Now, if it equaled something, we could rewrite it as an exponential using the definition of a logarithm. We don't have that, so for this one, we're just going to go ahead and use the change of base formula. If we look at the change of base property, the log base a of x is the log of any base of x over the log of that same base of a. Well, we don't have to pick a special number for b. We can just use our common logarithm, log base 10. And when we do that, we don't even have to write the number 10 because it's just implied. So I'm going to rewrite this as log x over log of 7. Okay, for d, this is the type of problem we dealt with in our first exponents units. You have two main ways to evaluate this, or I should say, simplify. We can either do the negative 1 property first, which would require us to flip the fraction, or we can simplify it first and then use the negative 1 exponent. I'm going to do the latter. So I look and I see x cubed over x, which is actually the first. And then for the y, I get y over y squared. And for z, I've got exponent of 2 on both the top and bottom. So, excuse me there. When I simplify, I subtract the exponents. 3 minus 1 is 2, so I get x squared. Remember, if you don't see an exponent, the exponent is 1. 1 minus 2 is negative 1. And then here, the exponents cancel out, and we just get 1. We don't need to write times 1 because we already have a number there. And that's to the negative 1 power. So when we take a power to a power, we multiply the exponents. So we get x to the negative 2 times y to the first, or just y. And if we want to write that without negative exponents, it'd be y over x squared. For e, we've got inside the parentheses, we've got exponentials with the same base. So with exponentials with the same base, we can add the exponents. So this becomes 2 to the x plus y power, all raised to the third power. And then we take a power to a power, we multiply the exponents. So we get 2 to the 3x plus 3y. Then for f, log 10 minus log 3. So looking at my properties of logarithms, I notice that, I have a log x minus log y here, which is the same as the log of x divided by y. So I could rewrite this as the log of 10 thirds. Okay, now in section 2, we are solving equations dealing either with logs or exponentials. If you have a log or exponential equation, what you're going to want to do is get the log by itself or the exponential by itself first. So for a, I'm going to divide both sides by 8. And I get 1.5625. So log base 2.5 of x is equal to 1.5625. Because the variable is in the log expression, what we're going to want to do is rewrite it as an exponential. So the base of the log is the base of the exponential. What the log expression is equal to is the exponent of the exponential. And that's equal to what we're taking the log of, which in this problem is x. So all we have to do is type in 2.5 to the power of 1.5625, and that would be our approximate answer. So we'll write about 4.186. Okay, for b, log of x divided by 10 equals -4. So using the quotient property, I can rewrite the left side as log x minus log of 10. And I know that's equal to -4. So you can type this in the calculator, but log base 10 of 10 is simply 1. So what I'll do is I'll get the log expression by itself by adding 1 to both sides. Log of x equals -3. Now, if I want to use our properties of logarithms, I could rewrite this as an exponential. Realize that when you don't see a number in log, it's base 10. So as an exponential would be 10 to the -3rd power equals x. We type in 10 to the -3rd power, and we get 0.001. Okay, for c, we've got a power function. The reason why it's called a power function and not an exponential function is because our variable is not in the exponent, it's the base. Now these are pretty straightforward. What we want to first do is get the power of the variable by itself. So for this problem, we're going to divide both sides by 16. So x to the -3rd power equals 15.625. So on the left side of the equation, we have x to the -3rd, but we want it just to be x. So we're going to have to raise both sides to an exponent to make it just x. So if you recall, when we take a power to a power in exponents, we multiply them. So in order to make this an exponent of 1, the exponent I need to choose is going to be the reciprocal of -3. So for this problem, we're going to take both sides to the -1/3 power. So on the left side, we get x. Then on the right side, we need to type in 15 to the 0.625 power. Now, it's important that you put the fractional exponent in parentheses. Otherwise, it's going to give you the wrong answer. And here we get 0.4. Now, if I want to check my work with that 0.4, all I have to do is type in 16 times 0.4 to the negative third power. And if my answer is correct, it'll equal 250, and it does. Okay, D. So it looks like we've got a radical, fifth root. We've got x cubed on the inside. So my recommendation is rewrite that as a fractional exponent, which would be x to the 3 over 5, or 3/5 power. So x to the 3/5 equals negative 3.6. So I'm going to raise both sides to the reciprocal power of 3/5, which in this case is 5/3. So we raise both sides to the 5/3 power, which gives us x on the left side and we've got negative 8.456. As a check, if I take that to the 3/5 power, I get my original right side of the equation, negative 3.6. Okay, now for E, the variable is in the exponent. So in order to solve for x, we need to get the variable out of the exponent, and we can do that with the log function. So I'm going to take the log of both sides. Now when I take the log of the left side, remember I can pull the exponent in front, which would give me x squared times the log of 3 equals the log of 560. So to get the x squared by itself, I'll go ahead and divide both sides by the log of 3. And I get about 5.76. So x squared is about equal to 5.76. So to find x, I'm going to take the square root of both sides. So the absolute value of x is equal to about 2.40. So our solutions are going to be positive 2.400 and negative 2.400. Okay, then for the last one in section 2, we've got a variable that's inside a radical. So we want to get the radical by itself first. So my suggestion is that you add 11 to both sides as your first step, which gives you 7 radical 4x minus 8 equals 28. Then the next step to get the radical by itself would be to divide both sides by 7. So we get radical 4x minus 8 equals 4. Once we have the radical by itself, we'll go ahead and square both sides to get rid of the radical. And when we do that, we get 4x minus 8 equals 16. So we solve for x. We add 8 to both sides. That gives us 4x equals 24. And divide both sides by 4. X equals 6. Now, anytime you solve an equation with a radical, it's always a good idea to make sure that this is actually a real solution and it's not extraneous. So when I go back to the original problem, if I type in 6 here, or plug in 6, I get 4 times 6, which minus 8, which is 16, and 7 times the square root of 16 is 28. So our answer is good. Okay, that will be it for part 1. Part 2 with problems 3 through this worksheet will be on the next video.